Today we're just doing the parent functions. I already answered that question. So, sound waves? Yeah, graphing paper will be a necessity for this assignment. What does a sound wave look like? Yeah, okay, good. So, this is what we're learning how to graph. It's generated by sine, cosine. If I were to put it on a set of axes, for sound purposes, the x-axis is time, right? Because music is measured in time, which is a real number. What's our real number measurement we're working with now? Degrees or radians? Radians. Okay. So your calculator will need to be in radian mode for this to work. Otherwise, on your screen, all you're going to see is like this mode, radians. Yeah. All right, we got a lot of words and definitions here first. This is the period of the function. That's one cycle. You can see that it repeats, right? In terms of sound waves, this is the wavelength. Okay, so if you're in a real world application mode, we're going to call this the wavelength of that sound wave. Okay. This is called the amplitude. And if you're in physics, in music terms, what is that? No. Pitch? No, I was looking for the setting. Not quite. Volume. There's two words for it. Pitch is a good question. I can't remember where it is now. I'll have to look that up. It has something. I think it has something to do with frequency. We'll get to that. The volume, so if you're looking at an equalizer, you turn the volume up, the wave will get higher. It increases the volume. When I plucked the guitar string louder last week, the only thing that changed was this is higher. Okay? That's the same thing. This is the math term and the music term. Same thing. Okay? Period's a math term, wavelength would be more of a physics term. Yeah, so this, I'll show you what that means, Sine, but I just wanted to get those two words in. So, what did you say, Andrew?
Physics, these are called crests and troughs.
Yep, they are. we're not going to worry about cosine for music, just sine. Okay? But we'll learn how to graph cosine. But the sine function is what we use for music. Okay? So this comes straight off of the values of sine. If I were to ask you what the sine of 0 is, right off the unit circle. So, what point am I going to graph? 0, 0, right? Right there.
The sine 0,
It's
that's
just
going
like
to be your x?
any normal function. 0 is your x, the output is your y.
Okay.
What is the sine at pi over 2?
Oh.
90 degrees is the pi over 2, but what's the sine value at that location? In the unit circle. So I'm going to graph we usually leave our x-axis in terms of pi. Okay. So pi over 2 and then 1. There are values in here. I'm not going to go over them. Okay, what about sine of pi?
Wait, you just did sine pi over 2.
Which is the value's 1. It's 0, right? So, dot. So, you have a lot of the knowledge you need to build this curve. Okay. The other values that I want to look at, sine 3 pi over 2, that's 1.5, right? Is negative 1. And then sine of 2 pi is back to 0. Yeah, if I'm graphing the parent function, this is my scale is usually pi over 2. Pi, 3 pi over 2, and 2 pi. So this function ends up looking like that. No. If that's your parent function for sine, now can it keep going? Yeah, it just repeats. So, if I head out to 3 pi and 4 pi, do I complete another cycle?
Yes.
Yeah, because every 2 pi I complete a cycle, so keep going. We're going to work Friday or next week on shrinking this and expanding it smaller, moving it horizontally. We'll get to all that, but I want you to know the parent function right now. Yeah, that, I'll teach you that next. Okay. You can also go backwards into the negatives. For time purposes, we don't do that in music, right? But mathematically, you can venture into the negatives. Okay? As far as I know, time travel is not possible. It's not Star Trek. Okay, thank you very much.
Darn.
Only
God.
What's the period of this function? 5. That's where it repeats, right? The amplitude. That means it goes from -1 to 1, right? Okay, keep that in mind. What's the maximum? Is 1 at what values of x?
Apparently you can't write.
Pi over 2, where else? What's that? These are the same height, right?
Yeah.
So they're all absolute maximums. This is 5 pi over 2. That's 5. Yeah. We have 2 pi is here, and there's another half of a pi, so 2.5 pi is 5 pi over 2. 5 over 2 is 2.5 fractions, right?
Yeah.
And we could also do, what's the next one going to be? 4, or pi. 1 plus 4 is 5 plus 1 is 9 pi over 2. You can keep going. How about the minimum?
Hey, is that 3 or 2 on that 5 pi? 2.
2, these are all 2's. Minimum's -1, right?
Yeah.
Where does that occur?
2 pi and 9. Yeah, well,
And 7 pi over 2, etc. Max is the mix, right? What's the domain? Recycling these algebra concepts so they're stuck in your balance. All real numbers, right? What's the range? -1 to 1, right? That's the only possible value. So this is basically it. One you'll be asked to do. What if I asked you to graph it from pi to 3 pi? What would it look like? You're going to start at pi and end at 3 pi. Okay. So that's one thing you'll be asked. Erase this and that, it's fine. Yeah, you can graph the whole thing and erase it. Okay, are you good with that? Cosine. Yes, I'm in a hurry. It was pi to 3 pi. Yeah, it's Wednesday, so we got about 5 minutes. Yeah. It's the same pattern, it's just shifted. Cosine, what's the cosine at 0? It's 1. So this starts at 1. At pi over 2 it's 0. At pi it's -1. 3 pi over 2, 2 pi. So cosine actually looks like this. Now, does that look more familiar now? It's shifted, sine shifted pi over 2 units. That's all it is.
Wait.
So you could start at -pi over 2 and do your sine curve. You're going to get cosine. And you can continue this. Whoa. Wrong. That is pretty cool, but not what I wanted.
What is that line?
I did it again. Okay,
You're
there you
on
go.
the wrong line.
I know, I get it.
But it's still cool.
Okay, cosine. So cosine is the same shape. It's just shifted backwards pi over 2 units to the left. Okay. I will talk about that next week. But all it would do is change how tall it is.
That's like saying that.
In front of cosine.
Oh,
In front of the x, that changes the period.
That's like saying the guitars are based on where you plug it.
Right, so musically, right. Musically,
Hey, Arthur.
we use the sign for a reason. Okay, because it starts at 0, 0. Cosine is useful in certain situations, so we have it.
So when cosine equals pi, does that mean that it equals -1/2?
Cosine at pi,
Yeah. So does that mean it equals
-1.
So then how is it that when sin to pi?
Sine of pi is 0.
Yes.
Sine of pi is 0. Cosine of pi is -1.
So what's sine? Cosine. Sine of pi is
Montaigne.
So we're back to ground zero. I'll fix the confuse again. Do something. You can do it. It's too good to believe. Did you just confuse yourself? What does he have for -1 on? Okay, so the numbers.
Like on the bottom. Does it always?
Okay, so this one's the sine. That.
Oh, that's it.
Okay, so 3 pi 2 is what got him to the negative.
It's not due until Friday.
What the it's just
Is it always the same? Like, are the numbers? Yes.
Leave your papers on the desk.
Yeah.
Always the
Kind of
same?
shift right over.
But you only have the sine and cosine, right?
Yeah. It's like when I go to second.
Well, that's, I get lost.